resistor. Chapter 3 is about resistor. Okay, for subtopic 3.1, you learn about electrical conduction. You need to be able to describe microscopic model for current. So that one actually is a very small subtopic, but you still need to be able to describe the model of current. And then define electric current. So I is equals to dq over dt. I think before this you already encountered this formula. And then use electric current, the formula, and then Q equals to NE. And if you guys still remember Q equals to NE, actually you already made this one in chapter 1. Okay, for current, you basically can imagine that that one is like a river. Okay, saya ada student complain kata masalah current yang circuit ni is that they cannot imagine, tak nampak benda tu. So maybe to make things easier, kamu boleh bayangkan dia something yang physical yang kamu boleh nampak. Maybe it will help, maybe it will not, but you can try. Okay, so voltage is a force that push the current through the circuit. So ini imagine je lah, macam perumpamaan dia. So without any force, the current wouldn't be moving. So kamu boleh imagine kalau if I draw a circuit, okay, this is just a normal circuit with a power supply. This power supply is also called a voltage. Okay, sometimes called EMF, electromotive force. Electron motive force. So it is actually a force that push the electron to move. Okay, so I will discuss about the direction of current and electron after this, but for now, voltage is basically a force that push the current. So without any voltage or without any potential difference, there would be no current. So that's the idea lah. Okay, and then the second one is about resistance. Resistance, you can imagine that it is a friction that impedes the flow of current through the circuit. Okay, something like rocks in the river. So if you are imagining, if you have more than one flow of water, maybe ada here as well. Letak mana? And I'm going to bring this one a little bit down. Okay, let's see if I have one more resistor over there. So if you want to imagine that this one is like a flow of a river, if you have two types of resistor with a different values, and this one is R1 and this one is R2, so you can imagine if you have more resistance in R2, the current or the flow of water will try to go more on R1. So itu adalah sifat nature current lah. Dia akan pergi ke somewhere with less resistance. So you can imagine that this one is like a water, or you can imagine that this one is like a flow of traffic. Saya suka bayangkan dia macam traffic kereta tau. Jalan besar, jalan kecil, tapi sama je. Kamu nak bayangkan dia sebagai sungai pun tak ada masalah. Okay, the current is actually the actual substance that is flowing through the wires of the circuits. Okay, it is actually consists of electrons. Okay, so because of motion of electrons, there's actually current. So voltage push electron through resistor. When the electrons start to move, then only you have current. Okay, so far any question?
Okay, sir.
Okay. Okay. So microscopic model of current, this one is the thing that you need to know lah. Yang tadi tu introduction. So in wire metal, the charge carrier is free electrons. So basically, the charge is moving through the electron. So the charge carrier is actually the free electrons. The free electron exists in a metal. So you can imagine if I have a wire, something like this. So this is basically a wire. You have lots of electrons and this electron, you can imagine that it can move freely. Okay, so when there's a potential difference, there's a force that pushing the electron can move in one direction or another direction. Let's pergi sebelah jap. Okay, so here, without battery, if there's no battery, there's no electric field. Okay, when there's no electric field, this electron will move, but in random direction. It can move in this direction, and then goes up, and then it goes there. This sebenarnya bergerak secara rawak. So if the question want you to draw electron punya direction, make sure you draw something like a zigzag. Yeah? If there's no electric field, there's no potential difference, tak ada force yang tolak dia. Basically, they will move freely. Kiri, kanan, atas, bawah suka hati dia. This is the concept. Okay, if you apply a potential difference, so similar cases like this, just now I draw. So all of this is basically wire, cuma yang satu tu saya besarkan dekat certain part so that you can see what happen. Okay, so if you guys still remember, if I have negative and positive terminal, electric field pergi daripada mana ke mana, from where to where? Siapa ingat lagi direction of electric field? Chapter 1. Positif ke negatif ke negatif ke positif?
Positive to negative.
Okay, good, very good. So from positive to negative, that one is direction of electric field. Kalau kamu mesti ingat lah, kalau kamu lukis, if you draw positive charge, electric field dia keluar macam tu. Kalau negative charge, the electric field will be going inwards towards the charge. Saya kemas tadi. Okay, so if you have electric field in that direction, okay, imagine that I have electrons inside here. So electron will move in which direction? Ingat lagi tak? Okay, kalau kamu tak ingat, let's say if you guys don't remember, you can memorize lah. Electron, if under influence of electric field, it will move in opposite direction. Okay, kalau positive, it will flow in the same direction with electric field. Kalau negative, it will be in opposite direction. Tapi cara paling senang kamu nak ingat, you can see that this one is positive plates. On the left side ni kan positive, on the right side ni adalah negative, so you can see clearly that the electron will try to move towards the positive plate. So let's see if electron put it further to the right so that I can show that it is actually moving to the left. So the direction of electron actually it will still move randomly like that, zigzag, but in general we will try to move to the left. They still move random, tapi on average will move to the left. And this is what we call V drift. The left direction too is actually V drift. You call that one as drift velocity. So that one is actually just the average electron. So kat bawah ni ada dia punya definition. The freely moving electron tend to drift with constant average velocity. This is what we call the drift velocity. So ada satu tahun ni dia pernah tanya in past year, they ask you to draw the macroscopic model of current under the influence of potential difference. Macam ni lah. Dia suruh lukis yang apa ni, cylinder ni. So you need to show that the direction of electron actually move zigzag, masih lagi zigzag, but the V drift is actually straight towards the positive plates. Positive terminal. Okay, and then the direction of current actually moving from positive to negative. So current will flow from positive to negative, but remember, electron flow in opposite direction from negative to positive. Okay, this one is charge. Electron is basically a charge. Okay, you might wonder kenapa electron daripada negative ke positive and current from positive to negative. So the only reason is that actually when they discovered about current, they decided that the current flows from positive to negative. Okay, so later on when they discover that current actually from the source, actually current exists because of the motion of electron, then only they discover that electron actually move from negative to positive. So since they already decided that current moves from positive to negative, so they just leave it like that. Okay, so there's no scientific reason apa ke. They assume current flows from positive to negative, and kita stick dengan begitu lah. Current positive to negative, electron negative to positive. Any question? Ada soalan?
Sir, yang elektron tu sama dengan charge
Electron tu actually adalah charge. So electron ni actually adalah charge carrier. So dia bawa charge tu bergerak. So charge tu kalau nak bergerak dia kena gerak dalam satu medium lah. So the electron itself is the charge. So when we are talking about the direction of electron, we are talking about direction of charge as well.
Oh.
Yang positif dia tak bergerak, so tak ada masalah lah. Charge yang bergerak adalah negatif. The positif tu dia stick dekat satu tempat, dia memang fix point. Contoh kalau metal, dia punya definition actually bukan definition dia punya property is that metal has freely move electron. So the electron inside the metals can move freely. Itu maksud dia. Okay.
Okay, sir.
Right. So moving on to the next slide. Okay, this one is about electric current. It is a base and scalar quantity. So yang microscopic model tu hopefully kamu dah faham lah clearly. Kalau lepas ni kamu tengok wire, hopefully you can see, kamu boleh bayangkan dalam tu berfungsi macam mana lah. Jangan bayangkan dalam tu ada air pula, sungai. Okay, electric current I is a base and scalar quantity. So before this, I told you that the direction of current is from positive to negative. So even though current dia bergerak daripada positive to negative, dia tak consider sebagai vector tau, dia still consider as a scalar. It's a scalar quantity, means that dia tak ada direction. So direction tu kita decide ourselves macam tu je. So kalau kamu dapat dalam calculation negative, normally it means that the current that you assume in that direction is opposite the actual one. Later on we will discuss more on direction of current, so don't worry about that. The SI unit is ampere A. So remember, current ampere, resistor ohm. We consider a simple closed circuit consists of wires, a battery, and a light bulb as shown. From the diagram, the direction of electric field of current from positive to negative. Direction electric current is from positive to negative terminal. Direction of electron flows is in opposite direction, which is from negative to positive. So we already discussed that one, so it shouldn't be a problem. And in exam or in your syllabus you will see lots of example with a bulb, menthol. So this bulb or menthol actually you can consider that one as a resistor. So I can redraw this diagram in terms of circuit diagrams to something like this. A bulb is simply a resistor. The filament inside there is actually a resistor. Yang dekat dalam ni basically a resistor lah. Nanti kamu akan belajar pasal chapter power and everything, and then you need to be able to interpret lah. When they are talking about a bulb, they are talking about a resistor. Okay, the formula for electric current, it comes from the definition that the rate of flow of charge is actually the current lah. Current is the rate of flow of charge. So change in charge over change in time is actually current. Set that part. So I equals to dq over dt. if you want to find the values of current at that particular time. Okay, if I want to find some average values, it would be I equals to Q over T. So this formula actually macam interchange lah. Sometimes student pakai left, sometimes student pakai right. So you guys don't have marks for formula anymore. So as long as you substitute the correct value should be okay. Biasanya jarang student salah lah this part. Okay, 1 ampere is the flow of 1 coulomb charge through an area in 1 second. So that one is from the definition of ampere. Apa maksud ampere tu? 1 ampere means 1 coulomb per 1 second. Yeah, so maybe dia tanya kat objektif UPS, I don't know. Tapi final PSPM jarang lah ditanya soalan macam ni. And then don't forget, kita ada yang formula yang biasa kita pakai tu yang important formula, which is Q equals to NE. So Q is the charge, the total charge. Now N is numbers of electrons and E is charge of electron. So macam yang saya cakap tadi lah, electron ni is actually charge carrier. So kamu boleh imagine, katakan saya ada segumpal charge, katakan Q dia sama dengan 100 coulomb. So this segumpal charge is actually moving because of lots of electrons inside there. Ni konsep je lah. So if you want to use this formula, we want to find how many electrons is inside here. So that's why we want to use this kind of formula. So jangan confuse charge dengan numbers of electrons. Some student they got confused. Q dengan N tu dia confused. Dalam soalan lah, kalau dalam macam ni nampak obvious. So anyway, kita cuba tengok example. Okay, we start with example 3.1. Okay, so far ada soalan tak? Kamu masih wujud ke tak?
Ada sir.
Masih ada. Okay, baca soalan dulu. There is a current of 0.5 ampere in a flashlight bulb for 2 minutes. How much charge passes through the bulb during this time? So if I want to redraw the question in terms of circuit, I can redraw the bulb as a resistor itself. And then I just put certain power supply over there. So current is 0.5. So it's given I equals to 0.5 ampere. The current, 2 minutes. The current flows for 2 minutes. So T is equals to 2 minutes. How much charge passes through the bulb during this time? So if I want to answer that one, it's very simple question. From the equation of I equals to Q over T, I can rearrange this one and it becomes Q equals to IT. I can substitute the values of current and values of time. Make sure you change that one to SI unit, which is in second. So you get Q equals to 60 coulomb. Okay, that one's for question A. Senang je, tak ada masalah. For question B, a silver wire carries a current of 3 ampere. Determine the numbers of electrons per second pass through the wire. Okay, ada berapa banyak electron per second pass through the wire. So actually this one is a bit tricky because you have to read the question carefully. The question asks electrons per second. So if you want to answer, you need to answer to electrons per second lah. Okay. Maybe I can do it on this side. Barcode sebelah ni. Okay, for question B, they want to find electron per second. So numbers of electron is actually n. Per second is actually per time. So basically you want to find n over t. So if you want to find n over t, we come from the formula of I equals to, okay, we start with I equals to Q over T, where Q is actually equals to numbers of electron come from this formula, I equals to Q over T yang formula atas ni, and then the Q is actually equals to NE, formula down here. Okay, I think we should use capital N instead of smaller n, because normally smaller n represent numbers of mole. We're talking about numbers of electrons. So I changed that one. So this one will be NE over T equals to I. So the question wanted to find N over T. I can rearrange. So N over T is actually equals to I over E. So saya bawa sebelah je. This one is actually equals to 3 over 1.6 times 10 negative 19. This one is actually the constant value. So you get 1.88 times 10 negative 19. The unit would be electrons per second. Okay, patut ada space electrons per second. Equation number 2. B2. Tak muat pula. Okay, question B2, they want to find the amount of charge flows through a cross-sectional area of the wire in 55 seconds. So in 55 seconds, they want to find the amounts of charge. So that one is simple actually. It comes from formula I equals to Q over T. The question want to find Q, which is equals to I over T. Okay, and that one is basically 3. So the current is 3 ampere. Multiply with 55 seconds. You should get 165 coulomb. So you need to use everything in SI unit. Find out answer will be in SI unit as well. Remember, charge will be in coulomb. Okay, solution pun dah ada pun, so tak masalah. Okay, that's about it for chapter 3.1. So 3.1, in conclusion, I just write a conclusion over here. Okay, I'm going to repeat a little bit. Conclusion, in conclusion, if you have a wire or any metal that has a potential difference, positive and negative, they will have an electric field, which is from positive to negative. Okay, because there's an electric field, the electron inside the wire that can move freely, we tend to drift into opposite direction. So this is what we call V drift in that direction. Drift velocity of the electron. Okay, so the current will flow in the same direction with the electric field, but on the other hand, charge flow in the opposite direction. So this one is E, and it's actually a Q lah. So sometimes we represent that one as a charge with the electrons because the electron is the charge carrier. Ini dia punya konsep yang pertama. The second one is that you learn about the formula, which is dq dt is actually the definition of current. Okay, this one is for instantaneous, and for average, I can use I equals to Q over T. And we also know that Q is equals to N E. So the question, you can use this formula if you want to find the specific numbers of electron with respect to the charge. So biasanya kamu kira charge dia berapa. And then soalan ni, the next one, they will ask you to find the numbers of electron. Remember to use SI unit. And then itu je lah for this subtopic. Jangan saya fikir, saya macam nak cakap something ni, saya lupa sebab bunyi mesin angin tu buatkan saya terlupa nak cakap apa. Okay, tak ada apa kot. Okay, biasanya chapter ni student selalu disangkut sebab dia tak faham soalan ni nak apa. The definition like the rate of I, the rate of current, the rate of charge, dia tak biasa with that term. So the rate of charge actually represent current, I equals to dq over dt. So numbers of electron is n, the charge is actually q. So student mix up yang q dengan n tu dengan I dengan dq dt tu. So itu yang biasa berlaku lah. Anyway, we moving on to the next topic. Okay, so far ada soalan tak? 3.1.
No, sir.
Okay, kalau tak ada soalan, kita pergi seterusnya. Kamu masih bersama macam senyap. Okay, 3.2 Ohm's law and resistivity. So now we're gonna learn about Ohm's law. What is Ohm's law and what is actually resistivity, and how does that relate with the resistance? Okay, Ohm's law. Okay, ni muka Ohm's. Rasanya lah, saya pun tak pernah. Saya first time dengar. Okay, Ohm's law state that the potential difference V across a I flowing through it if its temperature is constant. So in your syllabus, when we are talking about Ohm's law, we are talking about a constant temperature. Okay, we have two types of material in this world. We can divide into two types. One that obeys the Ohm's law, another one that does not obey the Ohm's law. What it means by obeying the Ohm's law is exactly like this graph, where V is directly proportional to the I. So as long as the metal directly has voltage that is directly proportional to the current, that one we call as ohmic conductor. So this one is all the materials that obeys the ohmic conductor. The opposite of that is non-ohmic conductor. So that one is not in your syllabus, so you don't have to worry about that. Okay, and the key thing here is that the temperature is constant. Okay, that's why for your calculation, normally we will assume, except dekat dalam subtopic 3.3, all the other subtopic will assume that the temperature is constant. Sebab tu kadang-kadang kamu buat eksperimen, ada student suka tulis kalau temperature increase, so kalau kamu biar dia lama sangat, the temperature will increase, and when temperature increase, you have increase in resistor. So that's the concept. Yang betul, tak salah. Cuma biasanya when we are doing the experiment, the temperature is very small. Normally we neglect. Jarang-jarang kita ambil kira lah. So even in our calculation, we assume that the temperature is constant. So we have this main formula where V is equals to IR. I think semua orang dah tahu pun formula ni. R is a constant because at constant temperature R is constant. So V is directly proportional to I. Okay, so nanti dalam eksperimen, you'll be plotting this graph V against I, and you'll be finding the gradient M. So the M you get is actually the resistance, and you can compare this value with the theoretical value. That one is for your experiment. So cakap siap. Okay, resistance R is actually electric property which is impedes or limits current in electric circuit. So that one is the behavior of a resistor. It's a scalar quantity. This one tak ada direction, confirm. And then the unit is ohms. You can write V over A, tapi saya tak galakkan. The SI unit is ohm. Just write ohm. Okay, the resistance depends on the type of material. So ada certain type has higher resistance compared to other type. So dia memang ada. That one is what we call resistivity. Ya, nanti kita belajar dari formula resistivity tu. It depends on length. So you will expect if you want to have electrical appliance that has the most yang menggunakan electric yang optimum, you want to have appliance with the less resistance. You don't want the appliance to have very long wire. Dan kamu tak nak wire dia panjang lah, so that kamu akan ada lower resistance. The longer the wire, you have higher resistance. Okay, and then you have cross sectional area. So that one you can imagine that one macam river yang kita bayangkan lah, ataupun jalan. Saya suka bayangkan jalan. Kalau kamu bayangkan jalan tu mengecut, area dia mengurang, so you expect akan ada high resistance. Kalau sungai tu tiba-tiba kecil, air tu akan ada banyak resistance kat situ. So that's the concept. Kalau daripada sungai masuk laut, so lower resistance lah. And then another one is temperature. So the temperature dependence, we only focus that one in subtopic 3.3. Other than that, we focus that, we assume that the temperature is constant. In general, the resistance of a conductor increases with temperature. Okay, what is resistivity? So tadi is resistance R. Now we are talking about resistivity, which represent by a symbol rho. Okay. It's defined as the resistance of unit cross-sectional area per unit length of the material. So mathematically, you can write that one as RA over L. So you'll be using this formula RA over L. It's a scalar quantity. Saya rasa macam dah buka. Do not disturb. Anyway, it's a scalar quantity. It's measure of a material ability to oppose the flow of an electric current. The resistivity depends on the type of the material and the temperature. So, rho ni actually dia adalah constant value. It depends on the material. Contohnya, you have a specific value of rho for gold. There's specific value of rho for nickel, for silver. So that one's a constant. That's why this formula actually, most of the time, you guys will be using in a little bit different ways. Okay, biasanya kamu akan pakai R. I'm going to rewrite this one. Normally, you guys will be using this formula as R equals to rho L over A. So normally the question will want you to find the resistance instead of the resistivity, because the resistivity is actually a constant value. That one depends on the material. So for this one, if I rearrange in terms of R, I can write that R equals to rho L over A. Okay. So most of the time you might be using the right equation tu, yang equation belah kanan tu. Okay, a good electric conductor have a very low resistivity. So it makes sense lah kalau kamu tengok dekat equation yang belah kanan ni. If you have rho ni low values, R will have a low values. So we assume that one is a good conductor. A good insulator have very high resistivities. Okay. And a very good insulator is actually water. Nanti kamu boleh tengok lah, kamu boleh Google kenapa saya cakap water tu actually is a very good insulator, tapi bukan normal water. Okay, example. The next example, 3.2.1. Constant wire of length 1 meter and cross-sectional area of 0.5 millimeter square has a resistivity of that one. Find the resistance of the wire. Okay, this one macam saya cakap lah, kita biasa pakai equation yang R tu. R equals to rho L over A. So I can start with that. R equals to rho L over A. So given that the length of wire is 1 meter, the cross-sectional area A equals to 0.5 times 10 negative 6 meter square. Resistivity is given. That one is rho. You can try to look at the unit. The difference between resistance and resistivity is the unit. So if you have ohms meter, that one is for rho. So now you just have to substitute the values. 4.9. Okay, to some rho. Anyway, 1 over 0.5 times 10 negative 6. That one, if you can press a calculator, I think you should get 0.98 ohms. Okay, jawapan pun dah ada pun, so don't have to worry lah. Okay, example number 2. Two wires P and Q with a circular cross-sectional area made of the same metal and have equal length. If the resistance of the wire P is 3 times greater than that of wire Q, determine the ratio of their diameters. Okay, if the question want you to solve something like this, macam ratio, things like that, kamu ada beberapa cara untuk selesaikan. One, you can start with writing the ratio of the diameters. D over D. Boleh start with that. Tapi biasanya student akan sangkut lah, dia stuck, dia tak tahu nak buat apa. So, what you can do is that you can find any one of the properties that is given in the question and then you can start from that. Okay, contoh the two wires P and Q with circular cross-sectional area are made of the same metal. So that one is actually indicator that the rho is the same. Rho P equals to rho Q because it is made of the same metal. So one particular metal has one particular values of rho resistivity. Equal length, so that one is key for L equals to L. If the resistance of the wire P is 3 times greater than that of the wire Q, determine the ratio of their diameters. So it's P and Q, or you can write that RP is actually 3 times greater than RQ. So if you want to solve this kind of question, you can start with any of these properties. You can start with the rho equals to rho, you can start R equals to 3R pun boleh. So it's up to you. But this time I'm going to choose this one because I think that one is much simpler. Sebab kita dah assume yang ni sama je sama. Let's say if I write that one, RP equals to 3RQ, we can refer back to the formula of R here, which is rho L over A. Okay. This was rho L over A equals to rho L over A 3. Okay, the difference is that this one is for P and this one is for Q. Okay, we assume that the area is the same as well sebab, oh sorry, the area is not the same sebab dia kata diameter dia tak sama. That's why the diameter will come from the area. Okay, so dia tak ada cakap area sama, saya tarik balik. So what you can do now is that you can cancel out the L because L is the same, rho is the same, I can cancel out that one as well. So I can rewrite this one as A area for Q equals to 3 times area for P. Formula for A for circular cross-sectional area is equals to pi d square over 4. Okay, that one's from formula of pi r square, but instead of r, you write d because the question want to compare the diameter. So 3 pi d square over 4. I can cancel out the pi and 4. Okay, I'm left with dq square equals to dp square. So what I can write now is that I can write dq over dp square square is equals to 3. Jangan tinggalkan macam ni. You can do one more step. You can write, saya tak tulis kat bawah, saya tulis on the right hand side. You can take square root of everything and you get dq over dp equals to square root of 3. So the question doesn't state specifically whether they want you to find ratio of q to p or p to q. So you can write in any ways that you like lah. P over q boleh, q over p pun tak ada masalah. So if you want to write P over Q, dP over dQ, then this one will be 1 over square root of 3. Okay, so I think that's it for this subtopic. In conclusion, saya concludekan dia. Okay, in this chapter, you actually learn about Ohm's law, where V is equals to IR. So as long as the material obeys the Ohm's law, you will see that V is directly proportional to the I when R is constant. Okay, So I can draw the graph with something like this, and the gradient actually represent the resistance. Okay, and then after that you learn about a formula of rho equals to RA over L. So saya sometimes saya terconfused between rho dengan R punya formula, but you guys shouldn't have this problem lah sebab formula is given. So jangan, you can always check kalau every time kamu tulis, double check betul tak formula kamu tu. So the R here is equals to rho L over A. Most of the time you guys will be using the one in the right hand side lah. The rho here is a constant value. It depends on the material. So I think that's it for today. Ada soalan tak?
So far okay sir.
So far okay.
Faham.
Okay, kalau kita start di sini dulu, try to look at your tutorial. Mana tahu boleh buat sikit-sikit. Nanti kamu cuba buat dulu. Okay, I think itu cukup for today. Thank you everyone.
Thank you, sir.
Okay.
Thank you, sir.
Thank you sir.
Thank you, sir.
Okay.
Thank you.